Alright, time for another draftphysics.com, debatephysics.com. Also, video presentation still on thermodynamics. I guess we'll go back to the video where I left off and talk some more about it, but you can already see where it's heading in terms of this idea that somehow the universe isn't rebuilding and then falls apart and then rebuilds and falls apart. That's a cycle. It's not even that you call it falling apart, it's that it's, taking energy, pushing matter together. The matter falls apart back into smaller and smaller pieces, and the smallest pieces end up pushing that energy, that infrared radiation, back into the heat cycle. And so there isn't any catastrophe concerning running out of energy, running out of heat. The fact is that gravity's the heat engine in terms of its heat making something more complicated, clumping things into bigger and bigger pieces. And it does it very well. Jupiter, big giant piece made by gravity, made by heat, essentially, theoretically. Yeah. So this is the simulation. I guess I'll try starting it over just for the hell of it. And you'll see that they turn into more, the electrons attract the protons, and they will line up, every now and then, into chains that can become circles and such. And so there's all kinds of geometry. And like I said, this really hasn't been perfected because we don't have the inverse square law in the simulation, and because it's only 2D. So it's, it isn't perfect in terms of the pressure it creates. But you can sort of see that the dipoles will turn, okay? There's twice as much red here, twice the attraction, 1 unit of repulsion, so it's turning like a magnet would turn. And, it's just geometry from here on out in terms of a balance of power between the electrons and the protons. And that is the creation of a nucleus. So the key ingredient really is the neutron. It should never have been thought of as some sort of single player. It really is what the sun's making, is neutrons. And neutrons, with one more proton added, obviously become, it could be called a deuteron or something. And that is the helium nuclei that's capable of maintaining velocity. So the sun can explode and it can't shoot a bunch of protons and electrons into space, but it can shoot those into space. And that's how matter gets away from, that's how matter is moved through basically what is just heat. Okay, and the heat is the force. Alright, so enough of that. And then we'll just go through the list of, let's see if it does anything interesting. You never know when it's going to happen. So I have videoed it, but I just thought we would see if it'll do it on its own. Alright, so I've pointed out that 1/2 mv squared is incompatible, and you can just understand it logically with any kind of idea that you conserve momentum, because every time you take energy from a heavy thing to a light thing, or from a light thing to a heavy thing, you can't conserve both. And then something as simple as the law of the lever, alright, the idea that when you move something on a lever, you can create balancing velocities to masses. So you have an mv on one side and an mv on the other side, and they match. Okay, momentum is conserved. Kinetic energy is not conserved on a lever. So it's a big indicator that it's not real energy, because something as simple as a balance doesn't show any sign of it. Then I went, there's so many examples. Then you have the silly idea, and it's just a statement. It doesn't have any, there's absolutely no evidence of this being true. That it takes twice the energy to move something, 4 times the energy to move something twice as fast, and that accelerates into 25 times the energy to move 5 times as fast, and 100 times the energy to go 10 times as fast. Just insane numbers that aren't anywhere near the truth. And that something going 5 times as fast somehow produces 25 times the force, when you can understand you can spin a motor, and none of that's going to be true. None of it. For that reason alone, anybody reasonable listening to this video should have some sort of doubt in their mind and say, yeah, that does sound like that is not possible. 25 times the power, 25 times the fuel to go 50 miles an hour versus 10 miles an hour. No, that doesn't happen anywhere. You should be able to just concede that until somebody shows you some real hard evidence, this is not a good theory. All right, so then I did the, Jesus, can't read this, never can. Can't read my own writing. The bowling ball example, right? So the 16, you can document it. I did to some extent. We can't know precisely how much energy the pins get, so we could have some fudgy disagreements about how each impact takes place. But each impact momentum has to be conserved, so when the pin flies off, it's going to have a momentum. The bowling ball loses that much momentum. And if you do that math, there's no room for any extra pin movement. If you reduce the pin movement to the movement of single objects of a specific weight, like a 1 ounce ball, and you turned all of the energy into 1 ounce balls moving, the 16-pound ball going 8 miles an hour is going to move exactly the same number of balls of velocity as the 8-pound ball going 16. There's just zero evidence that the 8-pound ball knocks down twice as many pins, and the real hard evidence that it doesn't happen is no professional bowler uses the lighter ball, so it clearly doesn't work. All right, 4. What the hell? The ballistic pendulum. 99% of the energy lost. Now, see, the very idea that you somehow think, okay, maybe if you're one of the believers, you think heat is somehow doesn't conserve momentum. So you can move little things inside of something, and somehow it's not equal to momentum. That you don't, when you lose the momentum to friction, for example, somehow you could be making a lot more heat than your momentum equals. Like somehow it's not exactly the same thing. It's just small stuff moving. You're going from big things moving, a big thing moving, and you turned it into small things moving, and you still have to conserve the momentum. So 99% of the kinetic energy always has to be lost. It's a mathematical requirement in the sense that you can't recover it as energy. That's what the formula says. So if I do take a spaceship and I try to turn it by hitting it with a bullet, it won't do me any good because I can't convert the bullet into motion of the ship. I have to lose 99% of the bullet's energy. All I can conserve is the momentum it has. So the only thing I can get into the ship is the momentum. That number I can get close to 100% recovery. But I have to lose 99% of the kinetic energy no matter how I catch the bullet. So it doesn't matter what device I make to catch the bullet, I must lose 99% of the kinetic energy. Now, how can you make that logical? How can you put that in your brain and say, yeah, that all makes sense? It's just such garbage. All right, I think this is the 10 thing, but let's see. The 5 going 10 is the same thing. A 5-ton train going 10 miles an hour is the same thing as a 10-ton train going 5. And if you gave them a tug of war, they're going to come out even. It's the same energy, the same force, the same capacity to do work. Yes, one of them will impose the energy quicker, but the other one has the durability. And so there's just no, this shouldn't be a contest. And again, that goes back to the law of the lever. They're the same thing. I crash them into a lever or an obstacle of some kind that, balance, and they're going to hit, and there's not going to be any movement because, well, one of them's down here and one of them's going to hit here closer to the fulcrum. If they hit, nothing's going to happen. They're going to have to reflect because they do have the same energy, and all they do is apply it over a different period of time. All right, let's see what else we got here. So yeah, you can increase that, so I could do 5-ton train going 15, and then I could have a 15-ton train going 5. Those are equal, but your kinetic energy theory says you lost 3/4 of the energy. That's what it says. And it says, and they imply that there's some sort of deformation or bending or something. You can't bend anything because that would use momentum. You can't shoot something off because that would use momentum. So all you're left with is your notion that heat isn't momentum, when that's exactly what heat is momentum. It's motion given to something, and the motion had to come from something else moving. And it's just so logical and consistent, and it just makes so much sense. And I really just don't understand why there's just nobody watching this video who can reasonably understand that simple, the fact that the contradictions are all over the place. It's nonsense physics. It isn't sewn up or tied up or it's not in any way a finished or complete, as Einstein would say. It's an incomplete theory. And he was just being polite because that's what he said when he really meant it's garbage. So you must use momentum to make heat. You can't show an example where you don't use momentum to make heat. You have to lose momentum to make heat. If these experiments conserve the momentum, they can't be making heat also. It's just so simple. But anyway. Alright, so I'll go find the video and we'll continue with a little bit of that rubbish. But again, the whole idea that this entropy argument that everything has to go scaled down, when no, I can use heat to push two big things into each other and make a bigger thing. I can use it in chemistry. I can heat something and I can cause two atoms to collide and become a bigger, more complex atom. It's not a one-way street. I don't know why they think it's important to argue that it's a one-way street, because it's not. And clearly in the whole universe it's not. Because all of that little tiny motion, all of the radiation, every time the electrons and protons are jiggling in the universe, they're hitting radiation that's coming towards them. And what are they doing to that radiation? They're pushing on it. Right? You can understand, they're red shifting it, and they're blue shifting it. And more importantly, you could argue, well, what does that really mean? It means that they're compressing it, and they're expanding it, the space that it's in. So you can understand that the pressure in the universe is, in fact, controlled by that radiation. And that radiation comes from all directions, and it pushes everything together, and is constantly clumping matter. It's constantly doing exactly the opposite of scatter and disassociation and fragmentation and whatever other words you could use for entropy. And it's doing the opposite. Yeah, I think we're all the way back here still. So I guess some of the other video must have got, it's missing. So anyway, so how could
trillions and trillions of atoms, even in a tiny volume of gas, ever be studied? How could we come up with mathematical equations to describe all of
Right. We wouldn't even try. There's no real point. Who cares? All we need to know is how does it mechanically work. So again, if what you want to do is not perceive things as trillions of this and trillions of that and billions of that, you just want to understand what does one fish do. Once you understand what one fish does, then you can understand what all the other fish are doing, and you don't need to do it the other way around.
this. After all, atoms are constantly bumping into each other.
Right, so it's going to be all kinds of dimensional issues, and even trying, okay, to say, well, even if I know what each one is doing, if they're influencing each other, then I'm really going to be dead in the water, because they're going to be constantly changing each other's conditions.
Changing direction, changing.
So you end up with a three-body problem. But anyway, again, this is not physics. Physics is explaining to me exactly what will an electron and proton do in this circumstance, and then saying, okay, when I make an atom out of those electrons and protons, what will the atom do because of the way it's conditioned? That's physics. Physics isn't this nonsense that somehow I need to know what the number is here, some number. I don't need some number.
Speed, and there were just so many of them. It seemed almost an impossible problem. But then Boltzmann saw there was a way.
So he didn't see any of this because he didn't really understand any of this. Clearly, he didn't understand that the force is the same force creating gravity. The heat is pushing stuff together in the universe. That's what it's doing. It's not dissipating. It's not disappearing. It's pushing right now everything into big giant clumps.
Boltzmann saw more clearly than anyone that for physics to explain this new strata of reality, it had to abandon certainty.
Oh, so that's just such nonsense. So this has nothing to do with certainty. Just has to do with it's an insane number of things. There's no way we can actually stop the universe and, measure everything's position and velocity. We can't do any of that crap. There's no point in pretending they're not actual positions and actual velocities and actual directions and all of that crap. I guess I should say also that it's more than just gravity, right? It's charge, that once the stuff is put in proximity to each other, that really pushes it together. Makes it possible for it to get really close. All this, the wasted
Instead
time.
of trying to understand and measure the exact movements of each individual atom, Boltzmann saw you could build working theories simply by using the probability that atoms will be traveling at certain speeds and in certain directions.
So all of that is just so obvious. It's not even worth having a conversation about. Of course, you want to just find out the approximate. So you could do that with the rain, and you could just measure a raindrop's impact. And then you could do some sort of approximation on what the average raindrop is doing, blah, blah, blah. There's just nothing remarkable about any of this crap.
Boltzmann had
I wish this is how they thought of the universe. I wish they understood that this is actually what it is, okay? It's discrete things with motion, carrying momentum, and that they can give momentum to the things they interact with.
transported himself inside matter. He'd imagined a world beneath our everyday reality and found a mathematics to describe it.
So again, this math is useless. It's terminology that isn't real. Something called an entropy is not a real thing. None of this has anything to do with anything real.
It would be here, at this scale, that Boltzmann would one day manage to unlock energy's deepest secret.
So this is the scale that Einstein figured out. So this is what Einstein figured out, is that when something's jittering, a big thing, like even a piece of pollen, it's jittering because something is causing it to jitter, something else jittering beneath it. Something smaller is doing the real work. That you can't jitter unless there's opposing mechanisms. You need an oscillator.
Despite the widespread hostility to his theories.
So it wasn't widespread, and so this whole story is just a story. It just really has nothing to do with the truth.
Boltzmann's ideas were highly controversial.
Well, highly. The existence of atoms was not that big a challenge once you got to like 1850, so that's just nonsense. There's a huge number of supporting players, like Maxwell himself.
And you have to remember that, today we take atoms for granted. But the reason we take atoms for granted is precisely because Boltzmann's mathematics.
Oh, bullshit. So again, I mean, Boltzmann's mathematics has absolutely nothing to do with why I believe that atoms exist. So that's just hilarious. But of course, I mean, there's no other explanation for the elements, okay? So Newton already sort of diagrammed the logical obligations here, in that how could you possibly have conservation of identity? That is, you can't make the lead go away. You can mix it with other things. You can make oxides. You can do this. You can do that. But you can't make the lead go away. And the fact is that there could be tiny little pieces of it in things. So they already knew. I mean, it's just bullshit to say they didn't already know by inference or whatever you want to call it, that there were little tiny pieces of elemental substance
married up so beautifully with experiment.
So we won't see any of that. So no experiment will be shown here, or explained or diagrammed how any experiment shows how the universe doesn't have gravity in it. There's no experiment showing that. All this wasted time, la 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 la. Crap. So they go to some crappy, dilapidated building that's supposed to be something, I don't know. A hotel. This was the hotel he hung himself in. Who knows?
One of the most surprising aspects of this story is that many of Boltzmann's contemporaries viewed his ideas about atoms with intense hostility.
You already said that. The other guy said it.
Today, the existence of atoms, the idea that...
It's just funny that this is just all this drama, all this storytelling about his private life, all this crap. And it's not even this is not the kind of thing where, like, Darwin published the book or something, or there was like 3 people that knew the theory. This is something a whole bunch of physicists understood.
All matter is composed of tiny particles is something we accept without question. But back in Boltzmann's time, there were notable, eminent physicists who just didn't buy it.
Right, and for no good reason they didn't buy it. So Mach was famous for saying crap that turned out to be just nonsense. And they're going to use him as an authority. Einstein found him insufferable after a while.
Why would they? No one had ever seen an atom, and probably no one ever would. How could these particles be considered as real?
So again, all this about the fact that there was this smaller structure to matter, and then eventually the real important feature was creating charge. And so it wasn't until they had the electron and the proton nailed down that they really had the story. So this wasn't even close to getting to the more complete Maxwellian story.
After one of Boltzmann's lectures on atomic theory in Vienna, the great Austrian physicist Ernst Mach stood...
So great. not by everybody's opinion.
Up and said simply, I don't believe that atoms exist. It was both cutting and dismissive.
Oh, you're just amazing. So what? That's it? That's all it took to drive him crazy, and he killed himself. I mean, what a pile of shit story this is.
And for such a comment to come from a highly regarded scientist like Ernst Mach, it would have been doubly hurtful.
They argued that no, atoms don't exist. They're names.
Oh, okay. Yes, that's a really great argument. They're just names argument. We'll just forget about the fact that, well, we have no other way of describing elemental matter except to call it something. The little bits that we can break it into.
Labels, convenient fictions, calculating devices. They don't really exist.
So let's just understand, we can't break the element into something. We can't destroy elements. So clearly that was a big giveaway that, oh, whatever it's made out of, it's something small, and, you know, we can't do the alchemy thing. We can't just turn it into pure energy. All right.
We can't observe them. No one's ever seen one. And for that reason, so Boltzmann's critics said.
So again, Boltzmann's critics in some sort of category, and it's not really, it's just not a fact. I think if you surveyed most physicists at the time, they would say, sure, yeah, got to be made out of atoms. Got to be.
He was a fantasist.
But Boltzmann was right. He peered deeper into reality.
So right about anything. He was wrong to talk as if we can't, just as gravity clumps things, we can use heat to clump things.
Than anyone else had dared, and seen that the universe could be built from the atomic hypothesis and understood through the mathematics of probability.
So again, I don't even know how probability enters this, but again, because they're going to convert that into the fact that things aren't probabilistic, in the sense that they're going to start talking about random and spontaneous, and simultaneous isn't simultaneous.
The foundations and certainty of 19th century
Say just more trying to sit there. They're just trying to find an excuse to believe in the Holy Ghost.
science were beginning to crumble.
And again, this is all in the context where this guy wouldn't even start the video by defining what energy is. Wouldn't say the words 1/2 mv squared. Wouldn't say the words momentum has to be conserved. Wouldn't say any of it.
As Boltzmann stared into his brave new world of atoms, he began to realize his new vision of the universe contained within it an explanation to one of the biggest mysteries in science.
So this is the biggest, I mean, it's just such nonsense. This wasn't the biggest mystery. The biggest mystery is, how does a magnet work? Charge, how does that work? Those were the big mysteries. They still haven't figured out how gravity works. You know, they have much bigger mysteries to solve than this, whatever this entropy bullshit was. I don't even understand the mystery. How does the universe lose all of its energy when obviously it hasn't lost all of its energy?
Boltzmann saw that atoms could reveal why the second law of thermodynamics was true.
So the second law is saying that you must destroy all motion and convert it into heat that somehow never will do work again. Yeah, well, yes it will.
Why nature was engaged in an irreversible process.
So it's no irreversible process. It's being reversed every single time two bodies gravitate to each other, or every time an electron attracts a proton. It's being undone.
Atoms had the power to reveal what entropy really was, and why it must always increase.
So it doesn't. It doesn't always increase. It constantly, like I said, we can clump things. We're clumped right now by a little bit of sunlight. A little bit of sunlight hits the earth and pounds us into these big giant monsters that we are. You can break chemistry with light. You can make chemistry with light. There's no obligation to just break atoms. There's every kind of likelihood that you're going to push two together just as likely. So all of this is, I don't even know why this is a video. It's such an uninteresting subject, and it's so far from being the truth. There's no truth value here anywhere. Why is this a video?
Boltzmann understood that all objects, these walls, you, me, the air in this room, are made up of much tinier constituents. Basically, everything we see is an assembly of trillions and trillions of atoms and molecules.
And we know that inside of that now is electrons and protons, that there are no atoms. Atoms are just composites. You know, it's the real things moving in the universe, the real things that are the bumping particles are just electrons and protons.
And this was the key to his insight about entropy and the second law.
So there's no key. His insight is nonsense. It doesn't have anything to do with observed reality or even theoretical reality.
Boltzmann saw what Clausius could not.
Oh, maybe this is where I left off before. So maybe we did that for nothing. Because now they'll have the little jiggling thing again.
The real reason why a hot object left alone will always cool down.
So the real reason, so they're showing contact, and contact isn't necessary because we know it's going to radiate infrared radiation. The infrared radiation is the same infrared radiation, radio waves. Doesn't matter what gamma, doesn't matter what form it's in. And that's the stuff that pressurizes the universe. The universe is made out of all this force stuff right now, flying through you, into you, all kinds of stuff. And that is what's smashing everything together. And smashing together is the opposite of entropy.
Imagine a lump of hot metal. The atoms inside it are jostling around. But as they jostle, the atoms at the edge of the object transfer some of their energy to the atoms in the surface of the table.
Right, and if I put it in space, okay, where there's no other atoms to jiggle, it will just slowly but surely radiate all of its energy as force. Because every time the electrons do this, the atoms aren't jiggling, the electrons are moving. Every time the electrons push on the universe in a sense is pushing back.
These atoms then bump into their neighbors. And in this way, the heat energy slowly and very naturally spreads out and disperses.
So how is that entropy when it's exactly the same stuff? It's just atoms jiggling. You have less jiggle in the main thing that was jiggling, and now you have more jiggle in this stuff, so there's no entropy here. Because you still have the same. You haven't made it more discrete. You haven't made it smaller. You haven't made smaller atoms jiggle. There's no entropy here.
The whole system has gone from being in a very special, ordered state, with all the energy concentrated in...
I mean, you could understand it as almost a wave, like all the energy will dissipate out of it as a ring of heat. And that ring of heat will just travel right through that base if I made that base big enough. And there would be this section of the substance that would just keep spreading out. You know, so in that sense, okay, it's getting more spread out. All right. And then all I need to do is put two of those next to each other, and those spreading outs will push into each other and recreate something hotter.
One place to a disordered state where the same amount of energy is now distributed among many more atoms.
So that's all they're doing. They're just saying it's more atoms. So yeah, there's less heat per atom. But again, if I put two of those things next to each other, then in between the two of them, I'm going to restore that heat.
Boltzmann's brilliant
If I put four of them, I'm going to get more heat. If I put eight of them, I'll get even more heat. So I can increase the pressure by just putting more of them on the surface.
mind saw this whole process could be described mathematically.
So it's just almost too silly, right? The process of spilling milk on a tablecloth and watching it soak into the tablecloth. Yeah, wow, I need math for that.
Boltzmann's great contribution was that although we can talk in rather sort of
Douchebag, pompous, arrogant, nonsense ways about gibberish and nonsense in very elegant English. We can use very elegant English to say trivial, silly, goo-goo, gaga things.
casual terms about things getting worse and disorder increases. The great contribution of Boltzmann is that he could put numbers to it. And so
I do remember this, so sorry.
he was able to derive a formula which enabled you to calculate
Oh, bullshit.
the disorder of a system.
Bullshit. Shit equals
This is Boltzmann's
crap
famous equation.
log W. I mean, it's just, really, this crap. This isn't saying anything.
Be his enduring contribution to science. So much so, it was engraved on his tombstone in Vienna. What this equation means in essence is that there are many more ways for things to be messy and disordered than there are for them to be tidy and ordered.
So, again, that's just too obvious, right? I mean, spreading out is more space. Compressing is smaller space. So, obviously, more things can happen in big space, lots of pixels, than can happen in a small space with very few pixels. There's only so many ways you can move when you're in a confined space. There's lots of ways you can move when you're in an expansive space. So, duh! I mean, come on. I don't need a frickin' equation for that.
That's why, left to itself, the universe will always get messier.
So again, it doesn't, as an absolute fact, that all of these little pieces that'll break off have a consequence. And the consequence is they're going to push, they're putting more force back into the universe. And that force will push other things back together again. I mean, it doesn't change the fact that, yes, this broken pieces will be more regular than, I mean, there's more tiny things than there are big things. Okay, yeah. So what?
Things will move from order to disorder.
And backward again. And again, it's a cycle. So this is just, again, it's just silly saying that the water goes into the clouds, turns into rain, and then the clouds all run out of rain. That's the end of it. I mean, what is this? This is such a waste of
It's a law
time.
that applies to everything, from a drop jug to a burning star.
So it doesn't mean anything, right? And so a burning star is, again, just such an anti-example in the sense that what's causing that energy to come out of that star is the gravity.
A hot cup of tea to the products that we consume every day. All of this is an expression of the universe's tendency to move from order to disorder.
And again, it's not a tendency. So even this example is a bad example, because what will happen to all this garbage, if you gave it a few million years, is that it'll start creating hydrocarbons and it'll very orderly arrange them and, in a sense, purify them. And you'll end up with something like crude oil, okay, which is incredibly organized energy.
Disorder is the fate of everything.
So it's it's just so wrong. He keeps saying it. This an hour's video of this nonsense statement made over and over again, and it's just not true. Take a break. All right, back.
Clausius had shown that something he called entropy was getting bigger all the time. Now Boltzmann had revealed what this really meant. Entropy was in fact a measure of the disorder of things.
So even their own understanding of the history of the planet Earth doesn't fit this, right? Because it was in all of this noise, and then it got quieter and quieter and quieter. Yeah, it's too silly. Where was I? Hit this button.
She is crumbling away. It's crumbling away now as we speak. So the second law is all about entropy increasing, which is just a technical way of saying that things get worse.
So it doesn't even make any sense. Things get worse and all this bullshit. What does that have to do with anything? I mean, kind of obviously things got hugely better, until like 1978, and then things started getting worse. Reagan happened. What is this? I know what peeling paint looks like. So I don't even know what the other fucking bullshit even was.
Boltzmann's passionate and romantic sensibility and his belief in the power of mathematics had led him to one of the most important discoveries in the history of science. But those very same intense emotions had a dark and ultimately self-destructive side.
Throughout his life, Boltzmann had been prone to severe bouts of depression. Sometimes these were induced by the criticisms of his theories, and sometimes they just happened. In 1906, he was forced to take a break from his studies in Vienna during a particularly bad episode.
In September 1906, Boltzmann and his family were on holiday in Buino, near Trieste in Italy. While his wife and family were out at the beach, Boltzmann hanged himself, bringing his short time in our universe to an abrupt end.
Right, and just the very fact that you'd even bring something like that up. I mean, obviously he hated his wife and kid. I mean, it's so cruel. Oh, you gotta clean things up. You can't do that.
But perhaps the saddest aspect of Boltzmann's story is that within just a few years of his death, his ideas that had been attacked and ridiculed during his lifetime.
So again, this is all storytelling about how much ridicule he took and how much attack he took and all that crap. Bullshit. Atoms were not that repugnant to the average physicist.
Were finally accepted.
And there was all good reason to, if all, what he was saying is that the universe is dying a heat death. Yeah, well there's good reason to say I'm not voting for that. Ugh, that was pleasant.
What's more, they became the new scientific orthodoxy.
And if that's all it is orthodoxy. All it is a dogma written by 10 people. They get to tell everybody else what they should believe, and it's not thought through at all. They haven't done any shit. They haven't done any experiments, really. They haven't tested any of this nonsense. They're just believers.
In the end, there is no...
It is kind of funny that they found whatever this building is, and because it does have these kind of attractive, interesting round feature windows and stuff. You wouldn't think it'd be in this much disrepair.
Escaping entropy. It's the ultimate move from order to decay and disorder that rules us all.
So it doesn't rule us all, but the fact that we will personally be, disordered and decayed, yeah, that's too bad. But all the other stuff we built is sort of kind of durable until the end of the, until the sun decides to melt everything.
Boltzmann's equation contains within it the mortality of everything, from a china jug to a human life.
And it's just not true. So that was just all so silly. Again, millions of years, oil. I mean, it's just it's an example of the opposite process right in front of you.
To the universe itself.
Heat and pressure create, okay? And the stuff they create can cause heat and pressure.
The process of change and degradation is unavoidable.
So whatever. I don't even know this change part. It's just a funny word. The motion in the universe must keep moving. But yeah, the fact is we could build it. We could reconstruct it into forms that would have a lot less movement in them.
The law says the universe itself must one
visible movement.
Day reach a point of maximum entropy.
So the universe isn't doing that. So again, I'll just say it again. We already know it. It's just obvious that that's not what the universe is doing. It's, it blows up, it expands, and then it contracts, and it expands, and it contracts. It's not just expanding.
Maximum disorder.
And it's not all about making disorder. It's about making order. Suns are an example of order, and they were made out of disorder.
The universe itself must one day die.
Fibber. I did speed this up a little. I should have sped it up a lot. So the whole video is about this mush. This is supposed to get me in the mood.
If everything degrades, if everything becomes disordered, you might be wondering how it is that we exist. How exactly did the universe manage to create the exquisite complexity and structure of life on Earth?
Alright, so exquisite. He has to throw that silly word in. Little monsters eating each other. Yeah, stealing each other's energy, right? So isn't that the irony of it? Is the whole mechanism is built out of making machines that are really good at stealing from other things their vital, fuel. Hilarious.
Contrary to what you might think, it's precisely because of the second law that all this exists.
So that's just, more hilarious. Yeah, you just talked about how it has to all disassociate and fragment, and then you say, oh, the same law says it doesn't disassociate and fragment.
The great disordering of the cosmos gives rise to its complexity.
Oh, that's just too silly. So, you just made the point that it's disordering, and then you made no connection to how does it give rise to the complexity then. You explained it's a one-way street. How did it get back the other? How did it get back? No explanation.
It's possible to harness this natural flow from order to disorder, to tap into the process and generate something new, to create new order, new structure.
Right. So again, he could have used oil as an example instead of using, cars or laser beams or some other thing where we take the disordered heat and oblige it to charge a battery.
It's what the early steam pioneers had unwittingly hit upon with their engines. And it's what makes everything we deem special in our world, from this car, to buildings, to works of art, even to life itself.
Right, so then why make the argument that it's a one-way street when obviously it's not a one-way street, and we can do it and nature does it? So why pretend? You could sort of argue that volcanoes before they erupt are the opposite process. They're creating order, and then they'll create a lot of disorder. Oh, this is just, look, I have a car, I can drive it.
The engine of my car, like all engines, is designed to exploit the second law.
So it's really not designed to exploit the second law. So what it's really designed to do is use, the fact that there's stored energy in the gasoline, and it's going to use the heat to make pressure. It's going to expand molecules. It's not really, heat isn't very helpful. The thing would work better, without the heat.
It starts out with something nice and ordered, like this petrol, stuffed full of energy. But when it's ignited in the engine, it turns this compact liquid into a mixture of gases 2,000 times greater in volume.
Right, so that's all. It's just an expansion. And everything's about expansion and contraction. Expansion and contraction. That's energy, motion. That's the simplest way to make motion, is to explode something. And then, the opposite is simple, but, because they don't have a theory of how things contract or how pressure is created, obviously don't understand that obviously the pressure is being created by force pushing things back. When they expanded into a field of force. The field of force pushes back.
Not to mention dumping heat and sound into the environment. It's turning order into disorder.
And the distillery that made the gasoline was turning sort of less order into more order.
What's so spectacularly clever about my car is that it can harness that dissipating energy. It can siphon off a small bit of it and use it for a more ordered process, like driving the pistons which turn the wheels. That's what engines do. They tap into that flow.
Right, and so all you're doing is converting heat into something bigger moving, right? And then the bigger thing moving is going to move into the air and make little things move again. It's going to vibrate the ground. It's going to make little things move again.
From order to disorder and do something useful.
Yes, so the key word there is useful, and useful is linear. So frankly, this isn't too useful, but that is. Yeah, okay.
But it's not just cars. Evolution has designed our bodies to work thanks to the very same principle. If I eat this chocolate bar packed full of nice, ordered energy, my body processes it and turns it into more
shit. Yeah. Oh, amazing. It transfers the energy, right? So it really isn't going to, it's not just about making heat. It's going to be making a lot of other things, and it's going to be doing the opposite of that entropy thing again. It's going to make compounds more complicated than the chocolate. Yes, it's going to make some smaller ones, and it's going to make some bigger ones. It's going to store some of that energy in fat cells.
Disordered energy that powers itself off the proceeds.
So again, this has so many holes in it. It's missing so many elements, right? Because, kind of obviously our body stores energy, fat. That's less entropy.
Both cars and humans power themselves by tapping into the great cosmic flow from order.
All right, so they just, this is just Yuck, the cosmic flow. Oh, God. This is disgusting. It's disgusting.
It's a disorder.
Although overall the world is falling apart.
Overall, it's falling apart because people have too little respect for Argyle socks. Argyle socks were invented by the British Empire. It was a brilliant invention, and people have lost all sight of how important Argyle socks are. Oh, I think that's a Scottish thing, isn't it? The Scots were those rude brutes. Oh, wait a minute. Scratch that whole part of the video. I was shit talking. It's just so bad. Oh, all this douchery.
Disorder is doing it in a seriously interesting way. It's like a waterfall.
Good. Let's see. Make it like something. Yes, please. Please give me an analogy. It's a flying platypus.
It's rushing down. But the waterfall throws up a spray, a structure.
Right. And if that spray was radioactivity, then the radioactivity could make something hot, and it could make it into a new atom.
And that spray of structure might be you or the daffodil or whatever. So you can see that
So it doesn't make any sense. What you just said, the water makes the spray. The spray is more diverse and particulated. Obviously, that's not us. We're the big, complicated bit, not the diverse, sprayy bit. We're not scatter. We're the opposite.
Finding of the universe, this collapse into disorder, can in fact be constructive.
So again, it doesn't make any sense. We're sliding into disorder constructively while we're building things that are not disordered. It's just too silly.
Steam engines, power stations, life on Earth. All of these things harness the cosmic
Hopefully we're heading for the end here.
flow from order to disorder.
So he did it again. Cosmic flow. The cosmic flow. Blah, blah, blah. Baby talk.
The reason the Earth now looks the way it does is because we've learnt to harness the disintegrating energy of the universe to maintain and improve.
All right, so the disintegrating energy of the universe. So again, it's not disintegrating. It's not going anywhere. The energy of the reflected, the energy absorbed by the sun was converted into the oil, solar energy. We're burning it. We're putting it back. It's reflecting off the moon. It's bouncing all over the place. All of this goes somewhere. All of this energy is going someplace. And it's been doing stuff. And the fact is that every single one of these little pieces of energy, if I could do a Boltzmann equation, I'd find out it has at least 13 billion year old history. That it's been bouncing around in this area for 13 billion years.
Our small pocket of order. But as humankind has evolved, we've had to find new pieces of concentrated energy we can break down to drive the ever more demanding construction of our technologies, our cities, and our society.
Oh, I think he's going to do it. He might even go to the silly experiments where they're trying to, duplicate the inside of the sun and make helium.
From food to wood to fossil fuels, over human history we've discovered ever more concentrated forms of energy to unlock.
So again, more bullshit. We discovered oil, period. That's all there was. The other things are weak by comparison. 8 to 10 times weaker.
In order to flourish. Now in the 21st century, we're on the cusp of harnessing the ultimate form of concentrated energy. The stuff that powers the sun.
All right, so we know the stuff that's powering the sun is gravity. So I'm just saying, I know it. maybe you don't know it, but that's what's powering the sun, is gravity. It's a big giant thing, right? And all the little pieces that are on the outside here are pushing towards the inside. And they're all like having 100,000 people on top of your head. They're squishing the fuck out of the stuff in the middle.
Hydrogen.
So the sun is, I would argue that the Earth could be a sun eventually. You just need to make something big enough. And all of the atoms, the heavy elements, probably get converted back into hydrogen. They get, disintegrated by the incredible pressure and heat.
This is the Culham Centre for Fusion Energy in Oxford, and at this facility they're attempting to recreate a star here on Earth.
So they're literally spending billions of dollars on this crap, and the theory is that somehow they're going to be able to create this huge amount of pressure and temperature, and they're going to somehow get more back, when I don't think the sun gets more back. Okay, I mean, the gravitational pressure is what is creating the stuff that's flying out, so there's a conservation in the sun itself. So if there were some above unity to capacity here, we'd have already known about it from the sun. The sun's not producing anything above unity. Something had to go into the sun for something to come out of the sun. It's not making force. It's not making force. I guess that's the key argument, right? It's not making heat. It's just redistributing it.
But as you might imagine, creating and containing a small star is not an easy process. It requires many hundreds of people and some extremely ingenious technology. This machine is called a tokamak, and it's designed to extract an ancient type of highly concentrated energy, the ordered energy of hydrogen atoms.
So it's really just neutrons. It's, you need to make neutrons. And so that's what all this is about. And again, the energy in the hydrogen atom, you could just kind of argue, what would the energy actually be? Okay, I mean, it's an electron and a proton. They like each other.
These tiny packets of energy were forged in the early universe, just 3 minutes after the moment of creation itself.
It's the pressure that makes all of this crap happen. Hydrogen smashed into another hydrogen atom at some normal velocity means nothing. It's about the speed at which the molecules are being smashed into each other that's creating the energy. So the energy is just about the pressure. The pressure is so high that it's pushing things incredibly fast. And so it's smashing two hydrogens into each other at an incredible speed, which means everything gets really compacted, and you end up with a neutron. But the point is that without the pressure, it produces nothing. There's no energy in the hydrogen. There's energy in the pressure you're using to compress the hydrogen. The hydrogen can't produce any energy. There's no energy in it. There's no strong force. There's no anything in the hydrogen atom that you can take energy. There's not a huge amount of compression. It's not radium, all right? It's not a whole bunch of stuff neatly packaged. It's not it doesn't have any energy to give. How else to say it? So it's not going to work, is my point. My point is they don't understand that you can't get any energy out of hydrogen unless you put the energy into the hydrogen. You have to move it at a very high speed, and the energy it's going to take to move the hydrogen at a very high speed is going to be more energy than you're going to get back from your neutron. Your neutron isn't going to have more energy than the hydrogen that went in.
Now, using the tokamak, we can extract the concentrated energy contained in these atoms by fusing them together.
So he said they can do it, but obviously none of them can do it. They're not going to produce more energy than they're putting in. And the only way they can do that is they have to break a bigger atom. They have to use tritium or some other kind of more complex atom, because hydrogen just doesn't have any energy in it.
Inside the tokamak machine, two types of hydrogen gas, deuterium and tritium, are mixed together into a superhot state called a plasma. Now, when running, this plasma can reach the incredible temperature of 150 million degrees. Large
For a millisecond, and blah, 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 blah. So it's all just such mush.
magnets in the wall of the tokamak contain the plasma and stop it from touching the sides,
So obviously they can't do any of that either.
where it can cool down. Now, when it gets hot enough, the two types of hydrogen atoms fuse together to form helium and spit out a neutron. Now, these neutrons fly out of the plasma and hit the walls of the tokamak, but they carry energy, and the hope is that this energy can one day be used to heat up water, turn it into steam, to drive a turbine and generate electricity.
Right, so they're saying, right, that the energy of the impact, so you're creating energy to make two cars crash, and that somehow you're going to get back more energy than you put in, and you really aren't.
Essentially, for a brief moment, inside the tokamak, a small donut-shaped star is created.
Right, no, that's true. It's not really essentially that.
The problem is, it's extremely difficult to sustain the fusion reaction for long enough to harvest the energy from it. And that's what the scientists at Culham are working to perfect.
It's a sort of boundary between physics and engineering. How do we hold on to this very, very hot thing, which is the plasma, and how do we optimize the performance of this plasma? So what we really want is that the particles stay in there for as long as it's all possible to maximize their chance of hitting each other. We're trying to push this to...
They're trying to create this tiny amount of space that something can be in, and it's not going to happen. You're not going to be able to duplicate what an insane amount of gravity created. This is like anti-gravity or something. You're just not going to be able to duplicate the conditions inside the Earth or conditions inside the Sun. You're not going to be able to do it.
The limits with what we have available in this machine, and whatever we can learn to understand this plasma better will also allow us to design a better machine in the future.
See, although it happens several times a day, oh, here we go. See, the scientists here all gather around the screens. Ah, okay, it's about to come on.
I mean, really, it's billions and billions of dollars on this crap. And they haven't dropped 4 pounds 1 foot and 1 pound 4 feet and measured how much energy they have. They haven't done that experiment. Yet they're doing this. I wonder if it really makes any of these noises.
What the tokamak is doing is mining the fertile ashes of the Big Bang, extracting
Oh, brother. Fertile ashes of the Big Bang. I don't see how it's doing that.
concentrated energy captured at the beginning of time. As hydrogen is the most abundant element in the universe,
So again, and you know, what makes hydrogen, and you mix it with oxygen, and it's then you can make, you know, something happen. But hydrogen,
if future machines can sustain fusion reactions, they offer us the possibility of almost unlimited energy.
if your theory of why of how that you're somehow mining the hydrogen atom itself for energy. And I would argue that there's no energy in it.
From a science that began as the byproduct of questions about steam engines, thermodynamics has had a staggering impact.
For an atom to have energy in it, it needs to have the tension between two competing things, like an electron on one side and an electron on the other side. And that idea that you've put two things that hate each other really close together. So it's like you're trying to duplicate the strong force. You're trying to make something where two protons are really close together. Obviously, individual hydrogen atoms don't have two protons really close together. So there's no rubber band there. There's no, like, say if I had a proton and a proton, I had an electron between them. So the protons can't see each other, can't repel. And then I just knock the electron out. You could understand that I have all this hate between the two protons. That's the expansion, that's the pressure. Hydrogen atoms individually don't have any of that pressure. So you can't use single hydrogen atoms. Now, whether you could use hydrogen 2, whether you can use hydrogen 3, right? Then it's a better argument. But it's just wrong to think that hydrogen atoms have a lot of energy in them, because they don't.
On all our lives. It has shown us why we must consume concentrated energy to stay alive, and has revealed to us...
Alright, so none of that was explained or proven or shown or any of that crap. So again, our body's doing the same thing. It does, it's breaking down just as many chemicals as it's building up.
How the universe itself is likely to end.
And we can see the cycle. It's constantly making complex elements, and then it's breaking other complex elements. It's constantly doing it.
Looking at the Earth at night reveals how one seemingly simple idea transformed the planet.
I don't know. So, simple idea. What was the idea? Fire. Yeah. Let's see. Transform the planet. I don't even know what to do with that. Right when the planet's being transformed, the biggest transformation was the 300 or so million years of the rule of plants and dinosaurs and fish and all that crap that ended up incompletely decomposing and putting a bunch of fuel in the ground, a bunch of carbon, and the planet got cold, and now we're heating it back up again.
Over the past 300 years, we've developed ever more ingenious ways to harness the concentrated energy from the world around us. But all that...
So yeah, that is kind of funny too. There's just no mention here of the fact that we're going to be burned to death, in the oven we've created.
Our efforts and achievements are quite insignificant when viewed from the perspective of the wider universe. As far as it's concerned, all we're doing is trying to preserve this tiny pocket of order.
Well, whatever. That's, whatever we're doing, it's all pretty bad. Just a bunch of people trying to, steal gratification out of any form of exploitation. They don't care. They'll kill animals, they'll kill people to make themselves happy.
The cosmos is falling apart.
So the cosmos isn't falling apart. It's just completely wrong. Every one of those photons coming out of those lights, every one of them will be doing work again and reconstructing complexity.
Although we can never escape our ultimate fate, the laws of physics have allowed us...
He said it again and again. He keeps saying it. Our ultimate fate that we have no good reason to believe. Yet I'm just going to sell this silly religion.
This brief, beautiful, creative moment in the great cosmic unwinding. My hope
So more
is that by
more bullshit about this great thing, all the war dead, all the things you could say that just weren't too fucking goddamn great, asshole. Shit.
understanding the universe in ever greater detail, we can stretch this moment for many millions, maybe even billions of years to come.
Doing what? Watching movies? Anyway, hold on a second. Alright, should be back. Hopefully this is recording properly. Almost done. Big finish.
We are surrounded by order. Over the last 300 years, we've developed amazing new ways to harness energy, and we've used this ability to transform our environment.
Maybe this is the beginning of the next one.
But all these structures that we see around us are just one type of visible order that we've created here on planet Earth. There's another type of invisible order, every bit as complex, that we only now be...
This is the information video. Oh, that's just so bad. I mean, it's just so bad. You know, physics talking about information. It's just such a pile of mush. All right, anyway. Patterns. It's all patterns. Yeah, so that's the end. Oh, good. It's over. Fuck. I'm glad we got it over with. So that was just so bad. So his quantum one is even worse, and I really should do that one when he's doing all the quantum stuff, because I can make much better arguments that I could make 10 years ago now. But it's all so dishonest. You know, this whole wave equation mush. Anyway. So, till the next time, I think it's enough. Yeah, it's enough. Get the hell out of here. Alright, so, till the next time and such. See ya. But you're probably a mortal enemy, so, you know. Probably best I don't see you. Fucker. Anyway, till the next time and such.